Welcome to this explainer. Today, we're diving straight into the core characteristics of cloud computing. If you look at how infrastructure has evolved over the last decade or so, the shift is just staggering. We are rapidly moving away from those rigid legacy systems into a paradigm where architectural dominance belongs almost entirely to the cloud. But what actually fueled that massive shift? Well, the answers lie entirely in its fundamental characteristics, and that's exactly what we're going to break down today.
Now, we all kind of get the broad strokes of modern tech environments, right? But to truly leverage the operational power of the cloud, we have to stop and ask ourselves, what are the specific traits that make it so incredibly powerful? What actually separates it from that static, legacy, on-premise infrastructure that used to totally dominate the industry? It's not just about taking your workloads and moving them off-site. As our source material outlines, there are 4 defining, highly dynamic features that completely redefine how systems operate. Let's get into them.
All right, let's start with Pillar 1, on-demand services. So the simplicity of this concept completely masks its incredible operational impact. I mean, think about the friction of the past. Building a system literally meant trying to predict the future. You were guessing your maximum capacity needs, you were pre-ordering massive server racks months in advance, and you were tying up immense capital. It was a rigid, high-stakes guessing game. Now, it operates on a direct cause and effect model. A user has a specific minimum requirement, maybe a sudden need for high-throughput processing power to run a complex data model, or just a vast temporary storage repository. And step 2, they just provision exactly what they demand. The cloud completely eliminates the latency of traditional procurement. It operates precisely based on your architectural requirements at that exact moment, giving you immediate, frictionless provisioning without all that upfront capital expenditure. It's a total game changer.
Moving right along to Pillar 2, scalability.
To really understand why this is such a huge deal, imagine a scenario that literally keeps engineers up at night. Okay, your application architecture is running flawlessly. Everything is great. But suddenly, a massive global event triggers a viral surge in your traffic. Users are suddenly flooding your API at 10,000 times the normal rate. What happens then? If your infrastructure is anchored to traditional static hardware, those physical limits become a hard ceiling. And you know what that means: throttled performance, dropped connections, and catastrophic system crashes at literally the worst possible moment. And this is exactly where scalability swoops in as your system's ultimate shock absorber. Scalability is just the ability to easily adjust your resources to accommodate those intense, varying levels of users and traffic. It essentially ensures that the back end can take an absolute beating while the front-end user experience remains completely seamless. The application absorbs the strain dynamically. It automatically expands its capacities so that proper functioning isn't just something you hope for, it's an engineered certainty. Now, scaling up to increase your network capabilities and handle massive traffic is the part everyone always talks about, right? But honestly, the true unsung hero of this characteristic is the ability to scale down. When that global event passes, the viral spike subsides, and your traffic normalizes, you can effortlessly reduce those resources. This is all about cost efficiency and resource optimization. You aren't trapped paying for idle servers that just sit empty 95% of the year just because you needed them for one massive spike. It's this elastic ebb and flow, scaling up to survive and scaling down to save, that makes the cloud so economically powerful.
Which naturally brings us to Pillar 3, flexibility and agility. Because your resources are finally uncoupled from physical constraints, developers are no longer tied down by rigid structures or incredibly slow, bureaucratic deployment pipelines. The real magic here is the agility it provides. We're talking about quick deployment, taking an idea from a local development environment to a live global deployment in a matter of minutes rather than months. It fundamentally changes how teams innovate. By removing the traditional bottlenecks of infrastructure management, your engineering teams can iterate faster, run way more experiments, and pivot their strategies with incredible flexibility. The environment literally moves and adapts at the exact speed of your engineering concepts.
And finally, we hit Pillar 4, security. Now, securing a static server room is one thing, right? You put a lock on the door. But how do you protect an environment that is constantly shifting, scaling, and deploying globally on a minute-by-minute basis? Well, our source material tackles this inherent challenge with a very vital promise: the data is going to remain secure. Cloud architecture uniquely solves the dynamic security problem through deep integration. Security isn't just a perimeter fence you build around the servers, it's baked directly into the fabric of the environment. Things like identity management, encryption, and threat detection are actively maintained protocols that scale right alongside the infrastructure itself. So even when you are rapidly provisioning thousands of new instances, the protection of your data remains a rigorous, automated constant.
Let's bring all of this together now in our summary of key traits. When we look at the entire framework of cloud computing, it's the interaction of these 4 characteristics that create such a profound shift in technology. Because the cloud is inherently an on-demand service, it enables immediate and completely effortless scalability. That scalability, in turn, fuels an environment of incredible flexibility and agility, allowing teams to deploy solutions at breakneck speeds. And crucially, all of this rapid movement and expansion operates seamlessly under a robust, integrated umbrella of maintained security. These aren't just isolated features, you guys. They are a cohesive engine driving modern architecture.
Understanding how these 4 pillars interact unlocks true architectural power. It's just a completely different paradigm for handling and deploying technology at scale. So, knowing how these deeply interconnected traits operate leaves us with one really powerful question for you to ponder today. How will you leverage these highly flexible, instantly scalable, and secure tools to fundamentally change the way you engineer and deploy your very next project? Thank you so much for joining me on this explainer. I really hope exploring these core concepts sparks some incredible new strategies for your own architecture. Catch you next time.